Hello friends, welcome to our new video. Let's see the today's problem. The today's problem is Bob and Hammer. Okay, so let's try to solve this. Before that, if you are watching our video for the first time, or if you did not subscribe to our channel yet, then please go and subscribe our channel and hit the bell icon as well so that you can get the notifications of our new video. Okay, so let's see the problem statement. Okay, here you can see that we have given a problem statement. The problem statement is Bob is at the origin of a number line. He wants to reach a goal at coordinate x. There is a wall at coordinate y. Okay, which Bob cannot go beyond at first. However, after picking up a hammer at coordinate z, he can destroy that wall and pass through. Okay, so determine whether Bob can reach the goal. If he can, find the minimum total distance he needs to travel to do so. Okay, so in the input we have given the three uh, numbers, that is x, y, and z. Okay, and if the bomb can reach the goal, we have to print the minimum total distance he can travel to do so. Okay, and if he cannot, then we have to print -1. Okay, so here we have given some sample input and output for this problem. Okay, so let's try to understand this problem first. Okay, so in this problem, what we have to do, we have given the three uh, coordinates. Okay, that is x, y, and z. Okay, and we have to find that if Bob can reach the goal or not, and if he can reach the goal, then we have to find the minimum total distance. Okay, uh, that he needs to travel to reach that goal. Okay, if he cannot reach the goal, then we have to print -1. Okay, so let's try to understand this first. Okay, so uh, okay, okay, so let's suppose this is uh, one number line. Okay, let's try to understand on this. Okay, and suppose this is the position of Bob. Okay, what we have to do this. Okay, so this is the initial origin of where the Bob is standing. Okay, now we have given the three coordinates. Okay, that is x, y, and z. Okay, so suppose uh, this is x coordinate. Okay, and this is y coordinate. Okay, and suppose this is z coordinate. Okay, and here at the y coordinate there is a wall. Okay, wall present. Okay, that's because of this wall, Bob cannot reach to this x, which is goal. This is goal. Okay, and this is wall present at y coordinate. Okay, and this is hammer. Okay, by using which Bob can destroy this wall. Okay, this is hammer. Okay, so in this scenario, uh, so we have to check that the Bob can reach the goal or not. Okay, so here you can see that here at the y coordinate there is a wall present. Okay, so uh, Bob cannot reach the goal. Okay, so what we can do, so from the z coordinate. Okay, by selecting the z coordinate, here you can see that after picking up a hammer at coordinate z, he can destroy that wall, and z coordinate, Bob can destroy this wall and he can easily reach to this goal. Okay, so okay, so what we can do here, mm, by using this hammer, Bob can destroy this wall and he can uh, reach to this goal. Okay, like this. Okay, but but if uh, okay, let's see another example. Okay, let's suppose this is on number line. Okay, and this is the origin where the bomb stands. Okay, now let's suppose this is x, this is y. Here the wall is present. Okay, here is wall. Okay, and let's suppose here is z present. Okay, and this is goal, and this is hammer. Okay, so in this example you can see that hammer is here. Okay, and origin bob is here. Okay, so in this case bob uh, do not he cannot reach to this goal at all. Okay, because he cannot break this wall by using this hammer. Okay, as if this hammer is uh, present to the left of this wall, then only he can break this wall and bob can reach to this goal. Okay, so uh, this is the example of. Okay, now let's see by using sample inputs. Okay, so what I can do, simply I'll copy this. Okay, and let's paste it here. Okay, these are the sample input. Now let's see by using this sample input. So I'll draw this number line. Okay, then suppose this is the origin where the bob is standing. Okay, this is the position of the bob. Okay, now in the first sample input you can see that the x is 10. Okay, so let's suppose this is x is 10. Okay, then this is y is minus 10. Okay, so these are the positive values and these are the negative values. Okay, from the right side of the bob it is positive values, it is from the left side of the bob it is negative values. Okay, so this is minus 10, which is y, this is x. Okay, and one is z. Okay, so this is z and its coordinate is 1. Okay, so in this sample input you can see that here in between the goal and bob there is no wall present. Okay, the wall is present at left side of the bob, so he wall cannot interrupt bob to reach the goal, so he can easily directly reach to the goal. Okay, so here the minimum distance to reach the goal, okay, which is 10. Okay, this is, let's suppose this is 0. Okay, and 0 to 10 it is 10. Okay, so minimum distance to travel is 10. Okay, now let's see for the second sample input. So the second sample input, let's suppose this is origin of the bob, which is 0. Okay, then it is 20, x is 20, which is x, then 10, here y 10, and z 10. This is z minus 10. Okay, so in this sample input you can see that between the goal and bob there is wall present. Okay, so directly, Bob cannot reach to the goal in this sample input. So to reach the goal, Bob needs to destroy this wall. Okay, so he can destroy this wall by using the z coordinate, which is this one. Okay, and after breaking this wall, he can reach to this goal. Okay, so what he can do, Bob can break this wall. Okay, so now after breaking this wall, now Bob can reach to this goal. Okay, so the minimum distance to travel is you know, to find the minimum distance. What we can do, we have to uh, multiply this z coordinates twice, which is z into z, or what we can do, we have to multiply the z by 2. Okay, so we'll multiply this z by 2. Okay, 2 into z, and we'll add the x into it. Okay, so to reach the goal, minimum distance is minus 10 into minus 10. So it is if we have to minus 10 minus 10 minus 10 into minus 10, 20. Okay, and we have to add the goal 20 and sign minus. Okay, 20 plus value of x is 20. Okay, so 20 plus 20 equals to 40. Okay, 20 plus 20, it is 40. Okay, so this is the minimum distance to travel. Okay, that is, this is minus 10, 20, 30, and this 10. So it is 40, and the sign, if there is a sign, minus sign, so we have to remove this minus sign. So for that, we'll use the math function, which is math.abs, to remove this minus. Okay, what we can do, let's try to write the code for this problem. Okay, so first I'll remove this. Okay, okay, now let's try to write the code for this problem. Okay, we have to take the input from the user. So here I will write the scanner c equals to new scanner, then system.in. Okay, then we have to take the three numbers, which is x, y, and z. Next integer y equals to sc dot. Next int, okay, and integer z equals to sc dot. Next int. Okay, so let's suppose this is for goal. Okay, and this is wall, and this is hammer. Okay, now what we can do, here we have to check that if the goal or value of x is negative or not. Okay, so if the value of x is negative, then we'll invert the positions. Okay, so what we can do, we'll invert positions if x is negative. Okay, so for that, what I can do, here I will write if x is less than 0, then what we can do, we have to uh, we have to invert the position, like x into equals to -1, or simply we have to uh, write like x equals to -x. Okay, anything you can write. So I will write x equals to x into equals to uh, -1. Okay, then y, same for y, equals to -1, same for z, equals to -1. Okay, okay, now what we can do, if we have to check that if wall or y is beyond the x, then what we can do here, we'll write the condition if y is greater than x, or y is less than 0. Okay, then what we can do, then simply uh, here we'll initialize one variable. Let's suppose answer, we'll initialize it with 0. Okay, now here what we can do, simply we'll write answer equals to x. Okay, answer equals to x. Okay, now what we can do, if the wall of y is between the goal, y is if y is between the x, then what we can do, uh, simply we'll do else condition here. Okay, and inside this else condition, what we can do, I will write one condition, that is if z is less than y. Okay, then what we can do, inside this again I will write if z is less than 0. Okay, then simply we are going to write answer equals to, we'll use the math dot abs method. Okay, and inside this what I can do, simply I will do 2 into z, and I will add x into it. Okay, now here what we can do, here I will write one else condition again. Okay, and inside this else condition I will initialize answer equals to x. Okay, and now what we can do, this is if. Okay, uh, mm, this is else, this is if condition. Okay, then here I will write one else condition. Okay, and inside this else condition simply I will assign -1. Okay, okay, now here what I can do, I will simply write system dot out dot println, and here I will print answer. Okay, so uh, we have written the code for this problem. Now let's see whether this works or not. So I'll copy this input, let's paste it, click on run. Let's see whether this works or not. Okay, output is 10. Okay, you can see that output is 10. Now let's see for this second sample input. So I'll copy this, click on run. For this output should be 40. Okay, you can see that output is 40. Okay, so let's take a random sample input. let's suppose 10, 1 and 100. Okay, let's see for this. So let's see what output. Okay, so for this output should be -1. So what I can do, I'll copy this. Let's paste it here. Let's see whether it works correctly or not. So okay, you can see that output is -1. Okay, so our all the sample inputs are showing correct output. Now let's try to submit the code and let's see whether all the test cases will pass or not. So click on submit. Okay, here you can see that all the test cases has been passed. Okay, so that's it in this video. अगर आपको वीडियो पसंद आया हो तो वीडियो को लाइक कीजिए और चैनल को सब्सक्राइब कीजिए. ओके, सो मिलते हैं नेक्स्ट वीडियो में.